Our next question asks us to give an example of each type of model. Some examples of those, if you look at page 11 in the text. For physical models, we had airplanes and model houses and model cities, things like that. Analog models, we had road maps, speedometers, pie charts. And then we finally have symbolic models. And these are simulation models, algebraic, spreadsheets, and these are the kind of things that we're dealing with in this class. The next question, number 7, is a bit of a trick question. The mean absolute percentage error is equal to 7, and the mean absolute deviation must be, oh, you can't figure that out from here. All right, the next one is a process capability index indicates a process is not capable at 6 sigma. At what level? Well, that's going to be anything that's less than 2. So if your process capability index is less than 2, then it's not capable at 6 sigma. Now, if it's greater than or equal to 2, then it is capable at 6 sigma level. All right, this next one, number 9, if sales are 500 and seasonal index is 0.91, got to find the deseasonalized sales for the period. Well, think about it. What would we do if we wanted to seasonalize some numbers? Well, we would multiply the 500 times the 0.91, and that would give us our seasonalized number. But if this is already seasonalized, we just do the opposite. So if we want to take a seasonalized number and then find the deseasonalized, we just divide. So 500 divided by 91, and I believe that was 549 was our answer to that problem. But let's do it in Excel real quick. So we have 500 divided by 0.91, whoops, 0.91 is 549. There you go. There's the answer. All right, back to our questions. All right, now we have probability of daily unit demand for ABC over the last year is 0, 1, 2, 3, 4, 5. And here are the number of units, and then these are the probabilities. So what we want to do is figure out the random number intervals to represent each event, and what's the demand if the random number 87 is selected. So we just kind of work our way up here till we find the one where 87 is below the next threshold. So here we are, that's 5. That's going to be 20 because I'm just adding the previous value, 20. And here we are at 40. I'm going to add 40 to this, so we have 65. And we add 20 more. Now we're up to 85. And now we go up here. Now we know that 87 is above 85, and this is our last range. So we are up into this range of 5 here. So you just kind of add these up and accumulate them as you go. So we have 5, then we have 20, then we have 40, then we have 65, 85, and you note I'm adding them up as I go. Each time I add the next one to the previous value. And when I get one higher than the number, that's the one I use. The first one that's higher than this value is the range that I'm going to use. Okay, now we have a pretty quick one. Profit equation for buying a good is profit is 5x, it's our variable cost, minus our fixed cost of 55. What's a break-even point? Break-even point is simply my variable cost divided by, or my fixed cost divided by my variable cost. 55 divided by 5 is 11. 11 is the answer in that case. Okay, number 12 is actually pretty easy. It looks pretty complicated, but it just requires that you remember a couple of things from the chapters. And in this case, this is going to be how we calculate the lower control and upper control limits on an X-bar chart. We also have an R chart as well that you need to remember how to calculate too. And if you remember, there was a crazy table in the textbook. It was also in the notes and the slides, and it had these columns A2, D3, D4, and depending on the sample size and whether you're doing an upper control limit, lower control limit, and the type of chart, it would tell you to use this column, or this column, and you'd multiply it by these other figures in a formula to come up with the values. So let's take a look at what we're going to do when we're trying to do the lower control limit on an X-bar chart. Now for the lower control limit on our X-bar chart, if you take a look at page 343 in the textbook, you're going to see this big gray chart. And you'll see that column A2 above it, it says the factor for X chart, and that's A2. And we're going to take a look at our sample size, which is 4. And so we're going to use the value right here. And in our formula, the lower control limit is just going to be our average. And we're going to take our our range in this case, and we're just going to multiply that by the factor that we have here. So in this case, we're going to have 0.1, and we are going to multiply our 0.73 times our 0.28, and that's going to be the value. So 10.1 minus, because we're going down to our lower control limit, 0.73 times 0.028. So let's calculate what that is. That is going to be, let me get rid of all this mess. In Excel, we're just going to say equals 0.1 minus, we'll go ahead and put this in parentheses here, 0.73 times 0.028. Now I'm going to hit enter, and there's our value, 0.08. That's the answer. Now our upper control limit, if we wanted to change that, we would just change this to a plus, and it would be 0.12. So we're going to go down for our lower control limit. We're going to plus this value. If we look up here at the formula, we're going to add the value, this area, to it to go up to our upper control limit, and we would subtract it to go to our lower control limit. The key is remembering whether you use the A2, D3, or D4, and the D3 and D4s are the ones that are used in our R chart. So there you go. And if you're looking for where that calculation is, that formula, it's at the top of page 345 in the text. You'll see upper control limit is X bar plus A2, which is that column we were using, times R bar. And remember, R bar is our average range, and that's how you calculate it. So just take a look at that and read over it and feel comfortable with it. I'd also feel comfortable, you need to feel comfortable also calculating the components of an R chart as well. So how would you get the upper control limit, lower control limits on an R chart? And that's on page 344. Okay. All right, now let's calculate our mean absolute percent error. And in this case, we have some forecast values, some actual values, and this is going to be a pretty straightforward calculation as well. I'm going to slide this down here, and then we'll go back to our buddy Excel, and we'll calculate this one out pretty quickly. I'll put it down below so I can see it. You guys won't be able to see it, but I can. And in this case, we had our forecasts, which were 65, 76, 56, 73, and of course 45. Now, and these are our actual values: 61, 71, 64, 78, and 46. So what's our absolute difference? It's just going to be the difference in these things. It's absolute, so we don't care if it's positive or negative. In Excel, I'll just say abs, and I'll just take this number and subtract from this one. Doesn't matter what order you do it in, since we're doing absolute in this case. There we go. Our absolute errors. And what we want to do is calculate, though, the percentage error. Now in this case, if I just take the mean absolute deviation, or our MAD, would be a different calculation, and in this case I would just say my average, which is average of these numbers right here. There we go. 4.6 is my average. That's my MAD, mean absolute deviation. However, mean absolute percent error is a slightly different concept. This will allow us to compare this forecast with others. So to calculate MAPE, we're going to take our deviation, divided it by our actual, which will give us our percentage. So let's go ahead and do that. So let's take our error here. We're going to divide that by our actual, and we're going to come up with 7%, 0.07. We're going to go ahead and copy that out. We were off by 7% there. 7%, 13, 6, and 2. And let's just go ahead and calculate our average there, which will be our MAPE. So we're going to do average, highlight these guys. So in this case, our MAPE is 0.07, 7%, which is the average of these values right here. All right, that's how we calculate MAPE. So to do it manually, though, you would just take the difference of these two numbers, and then, which is your forecast and your actual, and you would take the difference and divide it by the actual and come up with a percentage. And do that for each one of your values, and then just average those up.